Welcome, beautiful peoples in dark core. Approximately 252 million years ago, the Earth's biosphere suffered a tremendous blow. Almost 96% of marine fauna, around 70% of land vertebrates, and roughly 83% of insects perished within a period considered very short by geological standards. The causes of this disaster remain obscure, but whatever they were, the dreadful calamity did not wipe life off the face of the Earth. On the contrary, it proved to be a milestone that marked the beginning of a new era. This is when the most well-known prehistoric creatures, dinosaurs, emerged. The Permian-Triassic extinction event marked the beginning of the Mesozoic, a new era in the geologic history of the Earth. It began approximately 252 million years ago and lasted for around 186 million years. During this time, our planet was actively transforming and gradually assuming its present-day appearance. The most crucial tectonic process of the epoch was a splitting of the single supercontinent Pangea. First, it broke down into two landmasses, Laurasia and Gondwana, which eventually formed the continents we know today. With several large, mutually independent territories separated by seas and straits, conditions were perfect for independent ecosystems to emerge, giving rise to new evolutionary adaptations. In terms of climate, the Mesozoic was the warmest era in the history of multicellular life. Throughout this era, there were no permanent ice sheets. Still, temperatures dropped occasionally, forcing both flora and fauna to adapt to newly imposed conditions, especially during the Triassic period. The Mesozoic comprises three periods: the Triassic, Jurassic, and Cretaceous. The Triassic period began around 252 million years ago and lasted about 51 million years. Tectonic processes just started to break Pangea into separate continents, though the supercontinent remained largely whole during most of the period. The Ural Ridge, one of the oldest mountain ranges still in existence today, completed its formation during the Triassic. At the time, the mountains were solid and comparatively high. The period's climate was relatively dry and hot, resulting in many deserts and diminished inland water bodies. Atmospheric oxygen levels range between 10 to 15% for most of the Triassic, but around 215 million years ago, oxygen levels suddenly surged to 19%. Though the reasons for this remain uncertain, it's believed this had something to do with the evolution and spread of certain marine or land plants. Prehistoric seed ferns dominated the flora initially but were later gradually displaced by more advanced plant groups, such as cycads, ginkgo, and prehistoric conifers. Many of these orders survive to this day, though they are far less diverse now. Marine life was also evolving. Oceans, emptied by the Permian-Triassic extinction, were gradually repopulated by turtles and teleos, while the first ichthyosaurs emerged as large predators. These reptiles, although still primitive in Triassic, began adapting to aquatic environments. A prime example is Symbospondylus, which lived between 240 to 210 million years ago. This giant sea reptile measured 6 to 10 meters, fed mostly on fish, and had a long, thin body, half of which was a flexible tail, along with a large head and an elongated, sharp muzzle lined with small teeth. Its limbs resembled diving fins, but were likely used only to stabilize its body position in the water, and it swam by making wave-like movements. On land, the most common fauna were archosaurs, the prehistoric ancestors of dinosaurs, crocodiles, and birds, among others. By the middle of the period, the first true dinosaurs had evolved from ancient archosaurs as independent species, though it wasn't until the end of the Triassic that they began to establish dominance, coinciding with a spike in atmospheric oxygen and a sudden growth in size. Amid the giant reptiles, smaller creatures also thrived. One such animal was Oligokyphus, a small synapsid from around 200 million years ago. Measuring about 50 centimeters in length, it resembled a weasel, had fur, and was warm-blooded and herbivorous. It lived in regions corresponding to modern North America, Europe, and China. Although it's uncertain whether Oligokyphus had a pouch like today's marsupials, its skeletal structure suggests its babies were small and possibly fed on milk. It likely dug burrows and cared for its young, implying a relatively high level of intelligence. Sadly, these creatures went extinct at the start of the Jurassic period due to food shortages and increased competition. Nonetheless, there remain some of the earliest prehistoric animals that resembled today's mammals. The Triassic-Jurassic mass extinction marked the end of the Triassic period, wiping out numerous amphibians, archosaurs, other reptiles, and many plant species. Likely causes include volcanic activity, ocean level changes, and sudden climate shifts. This extinction cleared ecological niches, paving the way for dinosaurs to dominate the Earth's evolutionary stage. The Jurassic period followed, beginning about 201 million years ago and ending around 145 million years ago, lasting roughly 56 million years. It was an era of large-scale tectonic shifts. Pangea finally broke into separate land masses, divided by shallow seas. By the end of the Jurassic, the shapes of some modern continents had begun to take form, albeit in unexpected places. Isolated biosystems developed, meaning animals and plant abundant on one continent might not exist on another. The climate remained mostly warm and humid, although a brief cooling occurred at the period's end. Tropical forests blanketed large land areas, with cycads and gymnosperms being dominant, alongside widespread conifers. On land, dinosaurs thrived in both diversity and ecological dominance. From small, cat-sized saurians to massive herbivores, they filled every niche. Sauropods like Brachiosaurus, Brontosaurus, and Diplodocus were common. The largest among them, Titanosaurus, could reach lengths of 25 to 30 meters and weigh over 75 tons. These sauropods had a unique feature called a sacral brain, a widened spinal area that may have held a glycogen body to supply additional energy to their nervous systems. Other animals also evolved: mammals, reptiles, and arthropods. The oceans were populated with bivalve mollusks and large marine reptiles. Ichthyosaurus and Pliosaurus were top marine predators. Comparing the early Symbospondylus with its Jurassic descendant Ophthalmosaurus, which lived between 160 to 145 million years ago, highlights the evolution of aquatic reptiles. Ophthalmosaurus, with its dolphin-like body, crescent-shaped vertical tail, and powerful swimming capabilities, could dive to 600 meters, stay underwater for 20 minutes, and reach speeds of over 7 kilometers per hour. It fed mainly on mollusks and squid and had large, 10 centimeters eyes protected by bony rings, allowing it to see in the dark and dive where other predators couldn't follow. The final period of the Mesozoic was the Cretaceous, beginning 145 million years ago and lasting around 79 million years, making it the longest period of the era. Continental drift continued. India broke from Africa and moved toward Asia. South America moved westward, and by the end, the continents resembled their modern shapes. The climate was relatively cool, warming slightly from 100 to 85 million years ago, before cooling resumed. This was the age of the famed Tyrannosaurus and Triceratops, iconic Mesozoic dinosaurs. More significantly, flowering plants spread widely, transforming ecosystems. Trees and grasses strengthened soils and nourished a wider range of species, spurring diversification in both herbivorous dinosaurs and mammals. Reptiles still ruled, but mammals became more diverse. By the end of the period, distinct mammalian groups, like predators and primates, had emerged. One of the largest mammals of the Cretaceous was Reaponomamus, living around 125 million years ago. Up to 1 meter long and weighing 12 to 14 kilograms, it resembled a Tasmanian devil. Likely a scavenger, one skeleton was found with dinosaur remains in its stomach, suggesting it may have hunted small dinosaurs like Psittacosaurus. Large marine reptiles like Ichthyosaurus, Plesiosaurus, and Mosasaurus dominated the seas. Around 95 million years ago, however, their numbers dropped sharply due to the second oceanic anoxic event, linked to reduced ocean oxygen levels, possibly caused by volcanic activity. The end of the Cretaceous marked the coldest period of the Mesozoic. Many species adapted, including Nenexaurus, a relative of Tyrannosaurus rex that lived in what is now northern Alaska. At around 6 meters in length and 1,000 kilograms in weight, 8 to 9 times smaller than T. rex, Nenexaurus evolved to survive in Arctic conditions. Likely warm-blooded and fast-metabolizing like birds, it had layers of feathers for insulation and enhanced senses for hunting in polar darkness. It probably nested and cared for its young, and fossil evidence suggests a relatively large brain, implying high intelligence. Despite these adaptations, Nenexaurus and all non-avian dinosaurs went extinct about 66 million years ago in the Cretaceous Paleogene extinction event, which also wiped out marine reptiles, pterosaurs, and many other species. Dinosaurs left a lasting imprint on Earth's history, and their disappearance opened ecological niches quickly filled by birds and mammals. This ushered in the Cenozoic era, culminating in the rise of Homo sapiens, the self-proclaimed ruler of nature. Our evolutionary journey has only just begun, and only time will reveal what lies ahead for our species. Dear friends, if you have any thoughts on this fascinating story, feel free to share them in the comments. Your support means the world to us. These videos take immense effort to create. Please subscribe to stay connected with Darkcore, and a like from you will inspire us to produce and share new content even faster. Let's keep in touch. Thank you for watching Darkcore.